Hey, buddy, I'm right
But
here.
then,
You should go back to
you're
sleep.
assuming tan of x can equal 0. You do that?
Right, assuming tan x can't equal 0, you could divide both sides by tan. But, of course, we know that tan x can equal 0. In fact, it happens at 0 and at pi and at 2 pi and so on and so forth, right? And so wherever this is equal to 0, that'll be true. And so we can get all of those real values and say, okay, let's collect those. Then we can divide by tan and all that. And so what you're saying is one thing we could do to start off is divide both sides by tan. And you're right, we could do that. We could divide both sides by tan x. Divide this by tan x. Those go away, and now we have cosecant squared x equals what?
1.
1. Now what do we do?
Take a root.
Take a root. And what happens when we take a root?
Plus or minus.
Ah, good, right? So we get plus or minus 1. So in other words, we have two equations now. Cosecant x is plus 1 or cosecant x is minus 1. And we can see real easy if we just want to draw what cosecant looks like. Okay. We know that this guy blows up this way, he blows down this way, but we could find all of the points where that's true. Because we could say this happens at pi over 2. This is pi, this is 3 pi over 2. That's 2 pi. So 1 pi over 2, 3 pi over 2, how about 5 pi over 2, and so on and so forth.
It's like,
and we'll get all of those and all of those, right? Because this is 1, this is negative 1. And so we could find all of those. And in fact, we could do that kind of easily by just saying, well, and this is the way we're going to be doing it in your homework. The way I'm going to suggest to do it is you look at one full period, and you're always going to get two answers. No matter what trig function this is, if you have, say, let's say it's cosine, and you have some output like root 3 over 2, there's going to be two places here where you have those, and they're going to repeat every 2 pi, right? And so we're trying to find all real values of x. And so the way to go about doing this is to find both of those, and then you're just going to add 2 pi, or whatever the period happens to be. Cosecant, the period happens to be 2 pi. So we're just going to add multiples of 2 pi onto it, and we'll get all of them. So that's one way of doing it. But now, are we done?
no, because we
haven't taken care of tangent, have we? Right? Like, when we do this, we assume that tangent's non-zero, but we can see that wherever it is 0, you'll get some number times 0 equals 0, which will be true. And so what I'm going to suggest here is that the better way of going about doing this, and remember this came from, we got all of these solutions, which we haven't written down explicitly yet. These all came from cosecant squared x equals to 1. Okay, that's what we got from there. But this is the way I'm going to suggest that you deal with these, because you're going to see a bunch of these in your homework. Notice I put the homework at the bottom there. Okay. I want to make sure I am recording. Are we actually recording? And can the viewers at home see this? Yes, it looks like you can. Now, another way of dealing with this so that you don't accidentally, as you're like moving along and you get to here and you think, okay, I got all the answers, I'm good to go. A better way of doing this, I find, is to get everything on one side. Watch what we're going to do. I'm going to subtract off the tangent from the right-hand side, bringing it over to the left-hand side. Equals 0. And now what I can do is say, well, hold up. Like if this were x squared y minus y, I could factor out a y.
So factor out a tangent.
So factor out a tangent. I'm going to factor out one tangent. Okay, and now we have cosecant squared x minus 1. Check me on that. Did I do that right?
Yeah.
Check everything here. I brought him over there, leaving 0. I factored out a tan.
And cosecant squared x minus 1 is cotangent. I mean, no.
No. Maybe.
Wait.
Yes,
Wait.
it should be cotangent squared.
Yeah, cotangent squared. That's right.
Which we could, if we wanted to, we could use a trig identity to figure this out. in this case, it's not going to, it might help you a little, but whatever. You're going to end up doing about the same amount of work. In other cases, it might help a lot. In this one, not so much. But now we have something times something is equal to 0. So that gives us two possibilities, right? And so it's either the case that this thing, cosecant squared x minus 1 is equal to 0, or it's the case that tan x is equal to 0. You'll notice that this is this, and so we've already done that. We found that. We haven't written it out explicitly. We'll do that in just a second. But we got that from there. Now we just find out where tangent x is equal to 0. And I remember my graph of tangent x, it does this. There's pi over 2.
It's all 1 up 2s.
Negative pi over 2. It does again here, and so on forever. So that's at 0, at pi, at negative pi, at 2 pi. In fact, all integer multiples of pi will do it. So for this one, I'm going to say, so there's a couple different ways we could do this. I could write this as, I guess, 0 plus n times pi. Or
Just pi.
y, how about just n times pi? N times pi. And in your homework, I won't require that you do where n is an integer. Like, I get it. You get it. I get it. We all know that whenever you're going to write n in this homework, or from now on, we're talking about all integers n. And does that do it? Does that give us 2 pi? Yeah, because integers go through 2. What about negative pi? Well, yeah, negative 1. When n is negative 1, you get negative pi. What about negative 2 pi? Yeah, because when n is negative 2, you get negative 2 pi, and so on and so forth. So there's that. And this is what we mean by all real values of x. I don't want just the ones in the first period or the second period, right? I want all of them. This is how we could describe them. Now, this guy's a little bit more complicated. Because if I just said, well, I pick one of them, right? I get the one with the positive one. I could say, well, pi over 2 plus, and then I just say plus the period. What's the period of cosecant?
2 pi.
2 pi, so I could say 2 pi times n, right? And that will give me, but that's not going to give me all of them because there's another one here. But here's the thing, right? And let's just see. So there's pi over 2, here's minus pi over 2, minus pi, minus 3 pi over 2, minus 2 pi, minus 5 pi over 2, minus 6 pi, and so on and so forth. And so I claim that this is going to get all of these right there. And let's just check that. So I'm going to say this is true whenever x is equal to pi over 2 plus 2 pi n. And let's just see what happens. When n is equal to 0, we get pi over 2. So when n is equal to 1, we get pi over 2 plus 2 pi. Is that 5 pi over 2?
Yes.
Let's just check. Plus 2 pi.
Wait, pi over 2.
Thank you. And then over 2, that would be 4 pi over 2, which would be 5 pi over 2. I got that one.
Wait.
What? Ask.
What about the 3 pi over 2?
Let's, wait, what 3? Well, we're not there yet. This is what I'm getting at, right? And so this is what I'm saying. You could do this, and you think you're done, but you're not. And we're going to come back to that. But I just want to make sure that I got all of these guys here. Can we get the negative 3 pi over 2? What value of n here will give me negative 3 pi over 2?
Negative 1/2. Wait.
Oh, n has to be an integer.
Yeah, but. Oh, negative 2 pi. Yeah, negative.
Plus 2 pi times about negative 1. Is negative 1 an integer?
Yes.
Yeah. And that's the same thing as pi over 2 plus, or how about minus 4 pi over 2, which is negative 3 pi over 2. So yeah, we're going to get those too, right? This is the nice thing about, you just add integer multiples of the period, and you're going to get every one of these on the period. Now the problem is we got all these down here too. But the trick is exactly the same. You choose any one of them, doesn't matter. I choose to do it in like the canonical period right here. When you think about, and yes, it's cosecant, but we think about sine here, right? And like sine goes from 0 to 2 pi, so where are the zeros, or where is the solution of that in that first period? The other one's right here, right? 3 pi over 2. So I'm just going to say, okay, x plus 3 pi over 2 plus the period, because it's going to repeat every one of those periods, but it's going to do it in both directions. For every 1 period, every 2 period, every 3 period, every minus 1 period, every minus 2 periods. And so in other words, and
But couldn't you just do x equals pi over 2 plus pi times n?
you could. In this case, it works. In general, that's not going to work. Yeah, because, and so as things get stretched and stuff like that, and like for instance, if it were this, you would have, so what is this? Let's say this is cosine x right here. Cosine x, and we're trying to find out where is cosine x equal to root 3 over 2. Well, you tell me, what's that one right there?
Wait.
Root 3 over 2. Think about the triangle.
Pi over 3? Yeah. Oh, no, pi over 6.
Pi over 6, right? So let's see, why is this true? Get rid of the easy one here. Why is that true? Where's the triangle we know with a 2 and a root 3? 1, 2, root 3. Cosine is adjacent over hypotenuse. And so it must be that one right there to give me adjacent over hypotenuse. That one's pi over 6. And so this must be pi over 6. Well, what's that one?
5. Wait.
It's going to be over 6. That's the great thing about using radians. It's some pi over 6.
5 pi?
Yeah, well, let's see. Which one is in this quadrant? Because remember, here's the first quadrant, here's the second quadrant, here's the third quadrant, here's the fourth quadrant. So we're in the fourth quadrant.
From pi to 3 pi over 2. Wait. Yeah, so 5 pi over 6. Or no, wait, 7. Wait. Pi over-
You guys,
Yeah, 7.
think about it. Here's pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6.
Wait.
We're in the fourth quadrant.
Oh.
Yeah. Another way you could have done it is with distances. You say the distance from here to here is the same as the distance from here, which is 2 pi, to here. Right? And then we say, well, whatever 2 pi minus pi over 6 is, that's 12 pi over 6 minus 1 pi over 6 brings me down to 11 pi over 6. And so, for the cosine, you can see it's not, you can't just take this one and add pi. Right? Right? You see what I mean? Like, so you're going to have to deal with both of them. In this specific case, with the cosecant, and it happens to work because we're at the very top and the very bottom of the sine curves, or of the curve, right? And so it will work out to be, yes, you could write those, or you could write pi over 2 plus pi n, and it happens to work. But when you're not dealing with the maxes and the mins of these guys, then you end up with something that's not that easy. And so in this case, I would say for cosine x, I would say, if I wanted all real values of x, I would say that x is equal to pi over 6 plus whatever what's the period of cosine?
2 pi.
And every integer multiple in both this direction to give me all of these, and in the negative direction. You go back by 2 pi, you go back by 4 pi, and so on and so forth. The other one has got to be 11 pi over 6 plus, what's the period?
2 pi.
2 pi times n. Tell me you're not pooping, dude. Are you pooping? You should be sleeping. Go to sleep. Shh. Okay. So, questions on this? See what we started with, right? And yeah, we could have said, well, if I divide by tan, I'm good to go. As long as I remember that tan's non-zero, and then you say, well, where is tan 0? You happen to get the same thing here. But in general, it's not always going to work out this well. I suggest to get stuff on one side of an equation, factor it out, and then go from there. Because it's so easy to, especially as these get more complicated, you start doing your work, and you forgot that you did that with tangent in the first place. You forgot that you divided by it, and so now you need to check where is it equal to 0, blah, 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 etc. And so, yeah. Does that make sense?
Yeah.
Okay, so. Yeah, off to a rocky start today. Yeah, I'm not blaming you in particular. It was Father Tom. Okay, so in your homework, you'll notice I said every other odd, right? So start with 1, skip 3, go to 5, skip 7, go to 9, and so on and so forth. There are 2 sections that you're going to work through. One is like this. It gives you something like this and says, find all real values. This is what they're looking for right here. Your book does this section, 7.2, does a great job of explaining all this stuff. If you are hitting walls in your homework, you might want to look at that. But now there are 2 types of questions that are like this. This is one type of question. Actually, well, I mean, we could break this up into a lot of things. Oftentimes, you are going to want to, well, what I'm getting at is basically the 2 different kinds are where your variable that you're looking for is just its pure self. Then there are other ones where it's like 3x. Or it'll be something like, which is one we're going to do right now. It'll look something like this. So again, I'm not going to write this back up there. We are trying to find all real values, all solutions to the following. Find all solutions to sine. Oh wait, was this one that you're going to... I'm sorry, give me a second. 5, 9, skip it, do it, skip it. You're skipping 15, so we're going to do 15. Sine of theta plus pi over 4 equals 1/2. Okay. Now, another way they could have given you this problem equivalently would be something like this. 2 sine theta plus pi over 4 minus 1 equals 0. If you had something like this, what would you do? Well, you'd get the sine by itself, right? That's the idea. You'd subtract or add a 1 to this side, you'd divide by 2, and you would end up with this.
You said to get everything on this.
Okay. Yes, yeah, but ultimately, so now that you have, and really, that in general, that is what you're doing, right? Because now that you have this, think about the last thing. You have something equal to 0. And what did we do? When it was the case of cosecant squared x minus 1 was part of that, and we said that equals to 0, what was the very next thing we did? Now we solve that as its own thing. And we said, what would we do with this? And so, yeah, good catch. But what I'm saying is kind of the same thing. It's what I'm saying is like when you have multiple sines and cosines and multiple trig functions everywhere, it's good to try to get them all on one side, then factor everything down. But now once it's factored down, now the way that you go about proceeding with that is to do this. That's going to be your first step. And I say, just because we're running short on time, I was going to do another one after this, but let's go kill 2 birds with 1 stone. Let's say that it's 3 theta plus pi over 4. So this is one of the kinds that you're going to do. And do find all real values. Solutions. All real solutions.
So, cosine?
Well, yeah, here's the thing. In this homework, yeah, like yes, arc sine of both sides, but what is arc sine of 1/2?
Pi over 4. Yeah, pi. No. Wait.
What's the one with 1 and 2?
It is pi. Is there pi? Pi over 3.
You guys better
That's 6.
give that.
Oh,
on
6.
Okay, so what is it?
Pi over 6.
Yes, because pi over 6 opposite over hypotenuse. Sine is opposite over hypotenuse. So what I suggest we do first is say, you know what, let's go sine phi equals 1/2. Where phi is equal to 3 theta plus pi over 4. If you'd rather use x, use x. I mean, I just, theta, what comes after theta in my head is phi. Like, that's, you know, just like what comes after alpha, theta, right? As is like theta, then phi, and so on. So, okay. So now, I highly suggest, because it's going to be so easy, you're going to say, oh, it's pi over 6. But is that it? What does sine do? Forever and ever, and ever and ever, right?
So,
it goes on and on forever and ever in both directions. And so when it's 1/2, notice what happens. Oh, we get multiple solutions, don't we?
Yeah.
We found this one, and it was what?
Pi over 6.
And when we're over here, we're in which quadrant?
The second.
We're in quadrant 2. And so I'm thinking, okay, we have a pi over 6 right here. The other one has the same reference angle, pi over 6 right here. Hey, Father Tom said we could use the space. That's cool. He needed to use the he needed to use the nave, and so he said we could come in here.
Okay.
And so what is this one here?
5 pi over 6.
Yeah, if that's 6 pi over 6, then that's 5 pi over 6 right there. So this is 5 pi over 6. And then each of these repeat forever and ever and ever. So I'm going to say then phi is going to have to be pi over 6 plus what?
2 pi n.
2 pi n.
And also 5 pi over 6.
And also the 5 pi over 6 plus 2 pi n. So phi is equal to 5 pi over 6 plus 2 pi n. Now phi, we don't care about phi. Phi was not the goal here, was it? It was theta. We care about theta. And so let's substitute our theta back, or our expression with theta back in for phi. We have 3 theta plus pi over 4 equals pi over 6 plus 2 n. 3 theta plus pi over 4 equals 5 pi over 6 plus 2 pi n. Let's do a quick calculation. Let's get a common denominator. Well, because let me ask you, what are we going to do first? Let's say with this equation, the first thing we want to do in order to get theta by itself,
Subtract the pi over 4.
subtract the pi over 4. So that's going to leave me with something over 6 minus something over 4. What's a common denominator we can use?
24.
We could, but we don't need to go that far out.
Oh, 16.
How about 12?
Oh, 12. Wait, yeah. 16 times 12.
So what times 4 equals 12?
3. Yeah.
And what times 6 equals 12?
2.
There we go. So 3. So this right here, what I'm doing, to be explicit, is I'm saying pi over 6 minus pi over 4, 2 pi n, gave us 1 pi over 12. Pi over 12 plus 2 pi n, 3 theta.
Divide by 3.
Divide everybody by 3. And we're dividing everybody by 3. This guy and that guy.
Pi over 36.
So pi over what?
36.
36 plus, I guess that
2.
doesn't, how about 2 pi over 3? And notice, what's the period of this thing? If I told you, if I just gave you this and said find the period of this function, you would say, well,
Oh, it's
the
2 pi over
period equals 2 pi divided by whatever b is. B is 3. Oh, yeah, you're just adding on the period every single time. But we got to do that for all of them, right? So we got that there. We have to find the other one, which we did. Now 5 pi over 6 would be 10 pi. 10 pi over 12 minus, what did we say that was? 3 pi over 12?
7 pi.
Is that right? Yeah, okay. So then, theta, I'm just going to skip a whole bunch here. 7 pi over 12 plus, again we bring the 3 down, 2 pi over 3n. Now we have found all real solutions. They have that form. The hard, say again?
Did we divide 7 pi over 12 by 3?
Oh, we didn't. Thank you. That should be 7 pi over 30. Good catch, man. I'm impressed. fast. That was good. Very good. Okay, good job. You get a gold star today. I'm out of gold stars. Oh, man. Okay, so, questions on this?
If you did it with only variables, couldn't you, like, find a formula for this? Like,
I'm sorry? If I did what with only variables?
like, if it was, like, sine of...
A theta plus B?
Yeah.
Yeah? Oh, yeah.
We should do that.
Oh, you could. And, you know, that is doable. It's just, and yeah, you could. And in general, you'd be taking, because you'll notice this came out to be one of those values that you can compute. And so if you say, oh, it's arc sine 1/2, that's right. It just turns out that arc sine 1/2 is equal to pi over 6. And in your homework, all of these are going to be ones that you could calculate without a calculator. But if you didn't, if it were, say, 1/3, uh-oh, we don't know what that is. It would be arc sine 1/3, but we'd be missing the other one, wouldn't we? And you'd have to do something like this. You'd have to say, okay, well, 1/3 is about here. Arc sine 1/3 pulls back right here. Let's call that x1. So you have your x1. Now you're going to have to find your x2. And the way I would do that is say, well, that distance is that distance right there. That value is pi. And so I would say pi minus x1 is the other one. Or another, to be explicit, pi minus arc sine 1/3. Well, you're not going to have that in this homework. You're not going to have that in this homework. And then it would be x1 plus 2 pi n. And that would be x2 plus 2 pi n. So everything here would be the same. The only difference would be this would be something involving arc sine. This would be pi minus arc sine, right? Way different if it's down here. If it's negative 1/3, your arc sine doesn't pull that back, right? It's going to pull this back. So if you say arc sine negative 1/3, that number right there is a negative number. What a pain, right? And so, but yeah, there's ways you can deal with it and stuff like that. This homework won't have that kind of stuff. It will all of the answers will be stuff you could get, yeah, without that. So let's do one of these. Can I erase this stuff? Everybody got this. This is what you're doing, okay? And this, like, before I did on the quiz where I told you to do this, we should have had this beforehand. I was thinking maybe we'll see, and so yeah, whatever. We'll drop the little script. Okay, number 32. Same thing. We're finding all real solutions, and this is the easy type because you'll see 2 sine u minus 1 times cosine u minus square root 2 is equal to 0. Just go to sleep, buddy. You're so tired. So, you tell me, what are we doing?
Well, either the left one equals 0 or the right one.
There you go.
Yeah.
So now we have 2 equations, don't we? What's the first equation that we want to write down?
2 sine u minus 1 equals 0.
Okay, so 2 sine u minus 1 equals 0. And let's go ahead and deal with that. What do we get?
Add 1 to both.
Add 1 to both sides.
1. Yeah.
2 sine u is 1. It's the same thing we just did. You like how I do that? Okay, and so you know the solution to that. We just did it. It's u equals pi over 6 plus 2 pi n for any integer, and u is equal to 5 pi over 6 plus 2 pi n for any integer. For every integer, right? We want all the real solutions. So every single integer, positive and negative, that works. You'll plug one of those into there, that thing will be 0, making the whole thing equal to 0. Okay, great. What about the other one?
Same thing.
Okay, so what am I writing?
cosine u minus minus root 2 equals 0.
Okay. Now what?
Add the root.
Okay.
And then it's... Wait, equals root 2 over 1. 1 over... So it's pi over 4. 1 over pi is... Wait, yeah, pi over 4. No, pi over 4 would be 1 over root 2. So it's cos... No, I mean secant? Wait.
So let's just think about what this is. So like exactly, this is what goes through my head. I go, the one with the root 2 in it is this triangle. And I think, oh, so cosine of pi over 4 is 1 over root 2. Then I stop and go, wait a minute, is root 2 bigger than 1?
Yes.
Root 2 is bigger than 1. So what this says, so remember what we did once we got to here? I said I highly suggest that you draw a little picture and then do this so you could make sure you're not forgetting anything in a full period. Well, let's do the same thing with cosine and go, okay, cosine does this. That's 1 full period of cosine. Root 2 lives up here because this guy's 1. And we're saying, where do those two lines, where does that line intersect that curve? Never. It never does. And so there's no solution.
So it's just the first one.
So in other words, this will never be 0. It can never ever be 0. It's going to just bounce around from, at most, the closest it's going to get is root 2 minus 1. But, And so you never need to worry about it. That's not going to contribute anything to it, right? That's like saying, where does this equal 0? Like if you have 2x minus 1 times e to the x equals 0, you could say, well, I know this guy's never 0, so I don't need to worry about him, right? Same thing here. This is never equal to 0, so it doesn't contribute to your solutions, okay? So you're going to see that, and I want you to be able to identify that. It's good. And this is one of the reasons we like to, when we have an equation, if you could factor it, you can make your life so much easier by just going, wait a minute, can any of these be 0? Well, that I could see right away, that can't be 0, so I'm not going to waste my time, right? But do make sure that you don't just look at it and think, oh yeah, I'm done. Because if it were this, root 2 divided by 3 is certainly somewhere there, right? Root 2 over 3 is less than 1, and so you will have a solution. So don't just look at it and say, oh, I got a root 2 there, I'm done, right? You got to really think about it and go, yeah, no, okay, we're good. Don't look at me like that. Okay. I wonder if they... Oh, people at home can't even see him. This is perfect. We're going to keep you right here, bud. Okay. Okay, so, questions on that? Okay, so another thing, like, do try to think about this in terms of, well, yeah, if you could factor, your life is much easier. Sometimes you can't always factor, though, and so that's, that's unfortunate. Now, here's a problem. I looked at this one and I was like, what do I do?
No.
How do you do this? And I was like, oh, right, that's what you gotta do. Okay, so, well, here's the thing. Let's say you have something like this. Let's say you had a problem with this. What would you do?
Square both sides.
You'd square both sides, right? Because then you say, okay, well, if I square both sides, I get this. Okay, and now I could solve and do this and do that. And I should be good to go. I could use a quadratic formula, because I don't think that factors in the integers or rationals, right? So I'm going to use quadratic formula and find it, blah, blah, blah. But then at the end, right, I'm going to have to check. I'm going to have to come back here and say, well, hold up, because like if you got like -2 was one of your answers, and you plug it in there, the square root of -3 is not equal to -2, right? Like you're going to have, when you get down, whenever you square an equation, you're going to have to go back and make sure that all of the answers you get are legit. So watch this. Let's do number 50. This is number 50. And we'll use X. Right? And you look at that and you go, what am I doing? And up until this point in your homework, you've been given stuff like this, like cosine squared x plus 3 cosine x minus 2 equals 0. And you're like, yeah, it's a quadratic. I'll just say, yeah. It's like saying a squared plus 3a. And then you go through and blah, 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 blah. Then you get this. And you go, what? But then you remember, cosine and sine are related. There's an equation that basically what we started off with. And it's that cosine squared plus sine squared is equal to 1. And so I'm thinking, you know what? If I could get these things to be squared, and so the first thing I'm going to do, now I could just square both sides, and you'll get somewhere. But then think about what's going to happen. You'll get cosine squared minus, it'll be cosine squared minus 2 sine cosine plus sine squared equals 1. And actually, that's kind of cool because
it's just 1 minus 2.
1 minus 2 and then the 1 and the 1, and actually that's not too bad. That's actually not bad at all. You could do that. You could also bring this over, that's my intuition, is to say, I don't want a bunch of those, and so I'm going to do this. And then square it. Sorry about this. I should have put him over there. But then I square it, and I get cosine squared x. When I square this guy, first, outer, inner, last, is 1 plus 2 sine x plus sine squared x.
And that you can factor. Wait.
Okay, then, actually, this is probably a better way of going about doing it. So, but let's do it the hard way. Let's do it the way that Justin wants to do it. But here's the thing, right? It's like, well, wait a second. I have sine squareds and cosine squared. So I have a bunch of sines over here. If I could turn that into a sine, I could get all the sines over here. Yeah, and so I know that cosine squared is 1 minus sine squared. And so that's what I'm going to do. I'm going to say that's 1 minus sine squared x. Yeah. Now I add the sine squared over. I could get rid of these 1s. And I get 0 equals 2 sine x. Plus 2, it looks like. Yeah, plus 2.
Oh, sine squared, yeah.
Sine squared x. Okay, what can I factor out?
Sine, 2 sine.
I could factor out a 2 and a sine. Leaving me what?
Sine x plus 1.
Sine.
Or 1 plus sine.
Yeah. Okay. Now that 2 doesn't matter, right? Like it's just like if you ended up with some equation like this, x minus 1, you'd say, well, the 2 doesn't matter. It's either that thing is equal to 0 or that thing's equal to 0. The 2 doesn't mean anything in this case, so we can forget about that. So this gives us 2 equations. One is what, and the other is what?
Sine of x is 0, and 1 plus sine of x is 0.
1 plus sine x. Man, you are so loud today. So sine x equals 0. This should be easy. This is just that x is equal to n times pi for any n. You should know that. You should be able to do that if you wake up from your sleep. And somebody or you're walking down a dark alley and somebody holds a gun to your head and says, "When is sine x equal to 0? Any integer multiple of pi." That's you should be able to do that in a stressful situation. Now this guy. Okay, I'm going to use a graph. We could probably do this another way, but I don't want to miss anything. And I notice in one full period that only occurs once, right? Because there's -1. And I'm asking, where does -1 hit that? And it's, where is that?
2 pi.
This is 2 pi.
3 pi over 2.
Yeah. Okay. 3 pi over 2 gives you negative 1. So 3 pi over 2 plus all of plus and minus the period. Yeah. So x is 3 pi over 2 plus 2 pi n for any integer n. Okay, so those are those. Now, let's go back to this. Okay, so can I erase all the other stuff I did? You guys got all this?
Yeah.
Okay. What if I had gone this route instead? Where I just straight up, well, square both sides, see what happens, and I square both sides, and I get this. Well, one thing I notice is that the cosine plus the sine
Just go away.
yeah, well, it's like, plus the cosine squared plus sine squared equals 1. You see what I did? I just brought that over, and it's that, but I know that's equal to 1, right? So it's like, oh yeah, the cosine plus the sine is just equal to 1. And so I have a plus 1 and a 1, so it's gone. And so I have my 2 sine cosine equals 0. Negative 2 doesn't matter. That guy's going to give me that guy.
Oh, and the other.
So
Yes, this
is
then it's where is cosine?
Well, because cosine
Pi over 2
equals
plus
1 plus
pi
sine.
times it. Wait. Yeah, pi over 2 plus pi times it.
Cosine's
This occurs at pi over 2 and at 3 pi over 2. And so you would say, well, it's pi over 2 plus 2 pi n and 3 pi over 2 plus 2 pi n. Interesting thing is, this is the same. These are the same. So this, you might think, oh, I missed all these other ones. Well, it happens to be that as you go through, you're going to pick up all of these too, right? Because as the 2 pi n, right? Like, oh wait, where are you?
Ooh. Oh, you are.
You aren't. You're going to miss all of those. Ooh.
Only if it was pi. You could write it as 3 pi. Oh. Should that be pi times?
Well, no, you'll get your 3 pi. Wait. So, let's do it this way. That's the same thing as 4 pi over 2. Yeah?
Yeah.
This is the same thing as 4 pi over 2. And let's see, 5. This gives you, let's just start with this. 5 pi over 2, 5 plus another 4 is what? 9 pi over 2. 9 plus 4 is 13 pi over 2.
Oh.
7 pi over 2. Plus 4, 7, 8, 9, 10, 11 pi over. Ooh. Ooh.
We have all.
But this is insufficient.
Oh, why? What did we assume? What did...
Or is it? Remember what I said earlier? When you square both sides of an equation, you gotta do what? You gotta go back and check it. So this is what I wanted to show you this. Because there's a bunch of different ways you could go about getting answers, and you think, okay, I'm good.
Oh.
You check it in the back of the book, and you're like, what the? Wait a minute. You're either missing something, right? Like, if you wrote this down and the book said it's all of these, well, then you're missing something. Or it's, hi. Or no problem. So, or you did it the wrong way, or like you did it a different way, and now you have a bunch of solutions that aren't in the book. And so, what's going on here? Well, we're going to need to go check and see which ones of these work. And so, I'll leave that to you to figure out which groups of these do work and which ones don't. But I'm pretty sure these don't work. Okay? So, But yeah, so that's that. We still, I would go more in depth into that, but we are running out of time. Let me just check the time. Yeah, we're running way out of time. So, oh no, okay, that's right. These, so I said that there were two so then we had the find all real solutions ones, and then there was the second kind, which asks you to find solutions in an interval, and it's 0 to 2 pi. Okay?
That's what.
So this is much easier. So yeah, I'm sorry. I made it sound like, oh, geez, what do we do? Well, you're only going to be checking a certain amount of them, right? And I do suggest, like you could, I guess you could do it in one period here and be done. Although, in general, like, it will be better if you could do this in general and then reason beyond that. That's going to be easier, especially if when you have ones where it's, say, cosine 2x minus pi over 4, right?
Teacher, as soon as we got out, something felt right.
It's going to be, I think, it's just going to be easier to derive the general solution and then find out how many times that happens. Otherwise, you're going to have to graph this thing.
Which we don't like doing.
Which is kind of a pain, especially because you're going to have to compress it and think, okay, well, I guess it's going twice as fast, and now we've shifted it, and so where is that actually working? Or you could just get to this, which you've already been doing for half the homework up until this point, and then you just go and check. And so let's just see what that looks like when we go and check. Okay, so... Oops. Where was the one we picked up? It was pi, it was, or, oh, is it? Is it this? Pi over 2 plus 2 pi n. Which of these work? And so, first off, just in 0 to 2 pi, I could see that this guy is going to give me, well, if I plug in a 0, I get a 0. Plug in a pi, I get a pi. Or I'm sorry, plug in a 1 for n, I get a pi. Plug in a 2 for n, and I'm outside of what I care about, so I'm not going to worry about it. Here, I plug in a 0, and I get a pi over 2. Plug in a 1, I'm outside of 2 pi. Easy enough. This one, I plug in a 0, and I get a 3 pi over 2. Then I plug in a 1. Oh, I'm outside of the interval. Cool. Now be careful, because if it tells you to do this and your thing is tangent, it's not going to be 2 pi, right? Tangent is pi n, right? So you might have multiple things that you have to check. Be careful. But now we just have 4 answers to check. Let's see which ones work. Plug in a 0. What do we get?
1 minus 0 equals 1.
1 minus 0 equals 1. Is that true? Yeah, so my solution set, I'm going to go ahead and write it. 0 is one of them, okay? Now let's plug in pi. Cosine of pi is negative 1. Sine of pi is
0.
Is that equal to 1?
No.
No! Not a solution. Now, pi over 2. X is equal to pi over 2. I plug that into cosine. Pi over 2 gives me
0.
minus, plug in a sine, pi over 2 into sine. Is that equal to 1?
No.
Not a solution. Now, x equals 3 pi over 2. Plug that into here.
Pi. 0, 0.
Pi over 2, pi, 3 pi over 2, 0. Yes. Minus, what do I get with sine?
Wait. Oh, negative 1.
Negative 1. Minus a negative 1. Is that equal to 1?
Yeah.
Yeah, that is a solution. Now we have found all of them. And notice, this one didn't work. And that's what you'd find. If you were to try to do this in general, you would find, no, it doesn't work. But they're not asking you to do it in general. But depending on which way you chose to do it, you would have either ended up with these, in which case you'd end up with the correct answer, or you would have ended up with this and found, oh, I picked up some extra solutions, because that's what happens when you square both sides of an equation. So, woo! Okay, that was it. So the only other thing is like, yeah, we did that one. And then, like I said, you have ones that are stuff you're going to have to factor. So we'll do this real quick. So we've done ones where they gave it to you in factored form, and then they're going to give you these. So this is number 48. 2 sine squared u plus sine u minus 6 equals 0.
So sine u equals a or something.
Well, you could use a quadratic, but what would you like to try first? Anytime you have a quadratic equation,
Just factor.
you should try to factor it first. It's gonna be easier if you just try to factor
But
it.
you can't. Wait.
Can we? I don't know. I don't know. But if we can, it'll look like this. Oops, 2 sine and 1 sine. Now, 1 and 6,
3 and 2.
3 and 2, where do I want the 3 and where do I want the 2?
Wait, it's not. Yeah, it's not gonna. Oh wait. Oh, 3 on the right. I think.
3 and 2?
I think.
That would give me a 6 and a 2.
No.
Not happening. 3 and 2 gives me a 3 and a 4.
So the negative 3 and plus 2. Yeah.
Negative 3 plus 2. That should do it.
Yeah.
I should do it. So try that first. Now, it might be the case that you do have to use a quadratic. And if you did use a quadratic, oh no. I hope that didn't happen way earlier. Oh, buddy. I know. You should have slept, buddy. You're so tired. Okay, so now, it'll be worth it. Why don't we just do it? So let's say that you did use a quadratic, and you're saying, okay, well, this is the same as 2a squared plus a minus 6 equals 0. And you could say that a equals negative 1 plus or minus the square root of 1 squared minus 4 times a times c is negative 6 all over 2 times a is 4. A is equal to negative 1 plus or minus. Okay, what is that? 2 times 6 is 12 times 4 is what?
48.
48?
Yeah. So 1 plus 4. Oh, that's that.
That'd be 7.
Oh, wait, I guess it would have to, because we factored it, so it would have to. Yeah, over 4. And
So-
then minus 1 plus or minus
Negative
7
1 plus or minus 7.
over 4. So
either
it's 6 over
negative-
4.
negative 2
Wait, not 6.
or...
Yeah, 6 over 4 or negative
Yes.
8 over 4.
6 over 4 or negative 8 over 4. So, wait.
3 halves are negative.
Yeah.
Wait, what?
Wait,
Because
that's
it's
not
3
two.
halves, yeah.
Yeah, that
Okay,
works.
yeah. Hey, look at that. So it's either 3 halves or a equals negative 2.
Yeah, that's it.
Yeah.
Hey, look at that, because then you'd say, oh, it wasn't a that I cared about, it was sine. So sine of x is equal to 3 halves, or sine of x is equal to negative 2, which is what you would end up if you factored it. Okay, I like this method better. Whatever. But now wait a second, so that means we're solving 2 equations. Sine, or I guess it's u, is 3 halves. Sine is negative 2.
So,
You tell me, what's the solution?
arcs. Wait. Oh. It's the same. Wait.
It's...
You guys aren't thinking. What's the high? What's the?
Oh.
Oh, it can't.
We can't. No solution.
So you can say, U is arcsine of 3/2.
That doesn't.
That's no, you cannot plug in anything bigger because there's no output that's bigger than 1, right? So careful with that stuff. Turns out, no solution.
All that work.
All that work. But we didn't know that. We had to, we in order to know it, we had to do all that work. Okay guys, that's all I got for today.